Hi, my name is Andy Bloom. I'm a senior front-end developer here at Lullabot, and today we're going to talk about events in your JavaScript in the browser on your websites, get a little deeper understanding of how they work and how to use them, and how to debug some of the issues that you might have encountered with events in the past. So to start off, let's talk about what JavaScript is versus what the browser is. A lot of people kind of conflate the two, but there is a considerable difference, and this might help clear up some misconceptions. So to start, JavaScript is a compact programming language. It is single-threaded, and what that means is that all the action that JavaScript is going to do happens in the same pipeline. So in an operating system, you can do multiple things at once. In some other programming languages, you can do multiple things at once. But JavaScript is only able to do one thing at a time. And because of that, it is synchronous, it is blocking. Only one thing can happen, and the next thing that JavaScript wants to do can't start until the first thing ends. JavaScript on our websites runs in the browser's JavaScript engine, and it's doing things like arithmetic. It's going to do logical flow, so your if loops, your for loops, I'm sorry, not your if loops, but your if blocks, your for loops, your while loops. And it's got a handful of data types: strings, numbers, arrays, objects, those kinds of things. On the other hand, you also have browser APIs, and so that's an extensive and growing set of capabilities the browser has built in. Some you may have heard of are the DOM, the document object model, and all of the methods that go along with the document object model, the CSS object model, observers, fetch, history, all that kind of stuff is all in the browser. So how do these two interact? Well, we have this thing called the event loop, and it's kind of complex, but I want to try to break it down to something a little bit simpler. Ignore the memory heap piece that we have on the screen right now. That's not relevant to this talk at all. The call stack is going to be how functions are organized, and like we said, the first thing can't start, or I'm sorry, the second thing can't start until the first thing ends, and that's true, except for when the first thing calls another function, it goes on top of the call stack. And so you'll get this stack of functions. When we call one function, it goes on the bottom. And as we're working through that, if we call another function, it'll go as to the second item on the stack. And if we call another function inside the second one, it'll go as the third item. And we can't pull things back off of the stack until those other pieces on top of it are resolved. And so that's what we talk about when we talk about blocking code. We're talking about stuff that's running in this yellow box in the JavaScript engine and just piling on top of the call stack and sitting there and blocking everything else that needs to come in and run. When it needs to and when it can, JavaScript is able to offload that work to web APIs. So if you want to make an AJAX call, if you want to do set timeout or set interval, you can send all of that information over to the web API, and it will do the timer. It'll do the networking. It will do all that kind of stuff on its side. And when it's done, if it has a function to run, a callback function, it goes into the callback queue. And so while JavaScript is over here running stuff, it might be offloading a couple things over to the web APIs. And as soon as they're ready from the web API, they come back into this queue. And once JavaScript has finished working through all of its information in the call stack, all the way back down to being empty, it pulls in the first thing from the callback queue. And then it runs that through to completion. Then it calls the next thing in from the callback queue. And so what you get is this environment where JavaScript is going to do what it needs to. And when it can offload some work to the web APIs, it will do that. Then the web APIs will put those things back in line here. And then the JavaScript engine will pull from that queue when its call stack is empty. If this is something that's interesting or maybe still a little confusing, I highly recommend this video, and we'll include a link to it in the description. And it is from a JavaScript conference a while back. It's 26 minutes and 52 seconds long, but it is worth every second of it. And it demos this website. You can kind of see a thumbnail here of this thing called Loop, L-O-U-P-E. And it's a simulated event loop in the browser. And so you can actually write some basic JavaScript code over here in this kind of notepad looking area. And then it will visualize the call stack, the web APIs, the callback queue, and the JavaScript event loop working through the code that you've written. For now, just know that JavaScript can and frequently does offload some of that work to the browser. And a great example of that is event listeners. So what are events? What are browser events? Well, the event interface is a web API. And what that means is events are a browser thing, not a JavaScript thing. The browser has events. Those events move around. Those are where they're fired off, all that kind of stuff. And JavaScript is just given the ability to respond to those. Events exist in the browser, and then as a callback in the JavaScript, they exist as a way for the browser to kick off programmatic responses to interactions, to changes, to other significant things that happen on our site. Some examples of events, they can be triggered by user interaction. So mouse events, whether you do mouse up or down. So when you click the button down but don't release, that's a mouse down event. When you let the button go, that's a mouse up event. A mouse down plus a mouse up in a certain time span makes a click. Do that twice in a certain time span, you get the double click event. Mouse in or out, mouse enter, mouse leave, that's where the cursor is on the page and when it enters or leaves the boundaries of an element. Keyboard events, very similar to mouse up, mouse down. You have key down, key up, and a key press is the combination of those two in rapid succession. Focus events, as you're tabbing through a page and you can watch where the focus is going. When focus enters an element, we get a focus in. We get a focus element when the element has focus, whereas focus is inside that element. So if you have, for example, a button and you're getting focus, it will get the focus in and the focus event, and its parent will get the focus in because focus is inside that parent element. Other things that can kick off browser events, browser behavior, loading and unloading. When you visit a page, resources have to load, and the browser then fires off an event that says, hey, I've loaded this resource, I've loaded this resource, I've loaded this resource. At the very end of a session, right before our user clicks away from your page, it unloads everything, and it fires off a before unload event and then an unload event. Some newer ones coming to browsers these days are network status, so whether a phone is online or offline, and that can be useful for if you're running a progressive web app, or device orientation. If you have some things you want to do on your web page when a user takes their phone and rotates it from portrait to landscape or landscape to portrait. And then we can also artificially set off events in our code with the dispatch event method. So events happen on the browser side. Where does my JavaScript kick in? Well, we use the add event listener method on event target objects. An event target is realistically, for all intents and purposes, it's any element on your page. The class exists a little bit broader than that, but for the most part, it's any element on our page. And we can say then, select my article or my paragraph or my button dot add event listener, and then we can pass it an event type and an event callback. And that's basically just saying, hey browser, when event target, whatever I've picked as my target, has this event type on it, can you run this callback function? So if we imagine visiting a page, what the browser is doing, so you might visit the Lullabot homepage, a user is going to navigate to your page, and either the server or that browser cache will deliver a raw HTML file to the page, or to the browser, and then the browser is going to parse that information. It comes in just as text, and the browser has to parse that and build the DOM. And we'll talk about the DOM here in a minute, a little bit what that is. But this is where your inline JavaScript runs. So if you have any script tags and you have JavaScript in between those, as soon as the DOM is parsed, the browser can run that JavaScript. As soon as that's done, it says, hey, we've got some resources we need to go get. Anything that has the prefetch attribute on it, you might be some really crucial styles, it might be some font files, something of that nature. But the browser is going to go ahead and say, hey, these are very crucial. The developer, when they wrote this page, said these things need to get here as soon as possible. So let's go ahead and just go get those now. And then after it does that, it goes and it does its layout and paint operations. It does all the math of saying what images are here, what colors are here, what elements are here, and what are the styles, and what does the visual presentation of all of this information look like. It does those calculations. It paints the browser, which is just the fancy way of saying it puts the right colors in the right places on the screen. And then after that, it will fetch the remaining resources. And this is usually where most of your external JavaScript is going to run. So if you've put a script tag at the bottom of your HTML page inside the body, it's going to say finally, hey, we've got these other resources we need. I've finished doing all the crucial layout and painting. Let's go get all this other JavaScript. And so it goes and gets that, it comes back, and once that script has loaded, it runs that script. From there, in your script, you might call add event listener. You might have a button that you want to respond on a click to. Maybe it's like a hamburger button that pops open your menu, and so a user will then maybe click that button. And so we say, hey, by the way, on this button, watch for a click, and when it has a click, we want to run this one function. And the browser then stores that callback function. And at this point, JavaScript doesn't do anything else with the events or the function or anything. It's just ready to handle the stuff that needs to happen in the call stack and not block it. Everything right now is currently sitting over in the web API. Excuse me. So then if a user clicks on that button, the event happens on that target. The web API says, oh, JavaScript wanted to be notified that that event happened on that thing, and it said to give it back this function. And so it drops that function into the callback queue. It waits its turn in line if there's anything in front of it. JavaScript eventually pulls it in and runs that functionality. So what happens if we have multiple events going off at once? Because like we said earlier, a click is just made up of a mouse down and a mouse up. And so if we do that all in quick succession, you've got mouse down, mouse up, click. And so we've got multiple events, and they've all happened on the same thing. So how do we handle multiples? How do we make sure everything happens in the right order? Well, the browser fires off events in a predictable pattern that can happen in up to 3 phases. You've got the capture phase, you've got it at the target, and then you've got a bubble phase. And I like to think of it like a ball bouncing. And I'll show you a picture here of the DOM in just a second. But I like to think of it a ball falling down the DOM, hitting its target, and bouncing back up the DOM. But the browser thinks of it like the DOM. We might think of it like designers seeing components coupled into layouts. What is my spacing like? What are my colors like? How big is my button? How are they ordered? Content strategists might see article titles, article content, footnotes, asides, all that kind of stuff. Your developers might see different elements that are nested into each other, and they contain text or buttons or images or whatever. But the browser doesn't care about about the content on the page or how that content is presented. It's only caring about the DOM. What are the exact relationships between every single element on the page? So the browser stores its perception of the page in a flowchart kind of thing, a tree structure. You start with the document, and you work all the way down these different tendrils, all the way down to the lowest levels. And when an event happens, it starts at the top of that tree and works its way down towards the element. This is the capture phase. So you can imagine a click event on this anchor tag here. That event starts here, moves here, moves here, moves here. Once it's there at that deepest possible point of its path, that's at its target element. And in this case, target means what the browser was aiming for, not necessarily the user or the developer. If a user is aiming for one thing and misses, the target is whatever they actually clicked on, and that's what the browser is going to send that event towards. And then for some events, you have this bubbling phase. That event retraces its steps back up the DOM all the way to the document, and this is the bubble phase. Not all events bubble. There's not a great way to remember which ones do, which ones don't. You'll have to just check the documentation. It's important to note, though, that the event itself moves. You have a single click event, not a series of events that are happening on all those different things. You don't get one event for the document and then a different one for the HTML element and a different one from the body and a different one from the anchor tag. You get one event that starts at the document and it moves down that tree, and then it hits the target, and then it moves back up the tree. This is called retargeting, and you can actually see this if you want to console log out the event. You can save it in an event listener to the window object and then come back later and look at it. And if you log it out at the time that it happens and you come back and look at it later, you can actually see some differences between when it's at that target and once the event has fully completed its capture and bubble phases. so what this means is if you're going to interfere with or stop the event or any of that kind of stuff, you need to make sure you do it quickly because the browser is going to move that event. And so if you want to prevent its default action, if you want to make sure it doesn't move any farther along its path, if it's in some way cancelable or you can prevent its propagation, you want to make sure that happens. And we'll talk about what some of those things mean a little bit later. So why do I care? When you add an event listener, you can tell the browser which phase of that movement to invoke your callback function on. Inside your callback function, you can alter how the browser handles the event by preventing default behavior. You can prevent the event from continuing in its path along the DOM. And if you have things in the right order, you can even prevent the event from invoking any additional callbacks on that same target. So let's look at some code. If we want to add an event listener, we need to first get a reference to the thing that is our event target. So in this case, it's going to be a button. We're going to say const button equals document query selector button. And this will just give us the first button on the page. And then we can create a function called myCallback, and it's going to pass in the event, and we'll just console log the event. And then we can say button add event listener click and give it myCallback. You can and so you can do this three ways, right? You can give it the name of a function if it's a named function, like we have here, function myCallback, or you can pass in an anonymous function in the older syntax like this, or you can pass in an arrow function like this. All three of these will do the same thing, and all three of these will be different event listeners. The browser will look at this and say this is a reference to a named function, and this is a anonymous function, and this is, while they all do the same thing, they are three different functions in JavaScript storage. So default behavior. Event listeners will always fire on the target phase. Event listeners will fire on bubble phases by default on events that bubble, and multiple event listeners on the same target will be triggered in the order that they are attached. So if we think about the path that events are happening on, or the path that the event travels on as it's retargeted. It starts at the document, and by default, it's going to pass by all the parents and not fire off those event listeners. And then when it gets to the target, if there's an event listener there, then it'll fire it off. And then if it bubbles, if any of the parents have an event listener for that same event, it'll fire for those parents. And if you have multiple events on the same element, the order they're attached is the order they will fire in. And that's how you can make sure that if you're going to attach a mouse down, a mouse up, and a click, all three of those things happen very quickly. The events happen in a specific order, and they are attached in a specific order. Then we can have some options to modify that default behavior. So we can set an event to fire on capture. There are two ways to do this. You can either pass in a third argument that's just a true, and that'll attach it on capture, or you can use the options object and the key use capture, set that to true, and that will say then as the event passes an element, if it's in the capture phase, it'll go ahead and fire it off even before it gets to the target. You can also add in, if you're using the options object, you can pass in a once key, and if that is set to true, then event listeners will actually remove themselves as soon as they fire. And so what you can do is you can, I can't think of anything that you would want to happen only once off the top of my head, but if you had something where it was like, we want this to happen once, and then once it happens, we can just throw it away. We don't need to listen for it anymore. We only care about the first one. You can set that, and then you don't have to worry about cleaning up your event listener. So then responding to events, all events have these properties and methods. They all have a bubbles key, which will be either true or false. They'll have a cancelable key, which can be true or false. They'll have the current target, and that will point to the event target, which is probably an element that the event is currently targeting. And so like we talked about, it gets retargeted. That current target attribute will change as that event moves. We have a prevent default method. We have a stop propagation method. We have a stop immediate propagation method, and we'll talk about those in a minute. We have a target, and that is the event's actual target. So, and we're talking about the phases. Capture at target is when it's at that target, that's the element that'll be in the target attribute there. And then we have a type which will be string, and that'll be click, double click, mouse down, mouse up, whatever it is. Event types will also have additional relevant properties depending on what type they are. Click events will get the coordinates of the click. They'll get if there's any modifier keys held down. Keyboard events will give you the key code so you know which key was pressed. And focus events can give you the element focus was moving from or to, depending on whether it's a focus in or a focus out. So we talked about some of the methods that are on events. Events that would normally trigger default browser actions can have that action prevented. So you can think of like a link element. If you're going to click on a link that takes you to a new page, if you add a click event listener to that and you say event prevent default, then the browser won't navigate away. This is perhaps not a great idea for accessibility and usability because links should be navigating people away. But if there was some reason to block that action, you could do a event prevent default and then prevent the browser from doing its default behavior on that thing. Events that might trigger additional callbacks on elements further along the path can be halted. So stop propagation will say, hey, event, I know you're not done moving through your three phases yet, but we're going to go ahead and stop you here. You don't need to continue further. And this can be useful if you have an event that you know is firing something perhaps on the capture. You've put a click listener on the, for example, on a parent element and then on a button inside, and you want to listen for one set of clicks on the parent, but not on for another set, you can say, hey, for this set of clicks, we want to actually stop propagation because we don't want it to fire off this other callback method. And then stop immediate propagation not only stops it's moving along the path, but also says any callbacks that are set to after this one that's currently running, don't run those. We're just say, hey, event, we're just stopping right now. We're going to tell the browser, don't send any more callback functions down the pipeline. Removing event listeners. You can also remove event listeners, and this is great if you have functionality that you want to listen for a minute and then turn off. The trick is, though, you have to have the same function in the add and the remove methods. So if we look back at what we had earlier, button, document color selector button, you name your function my callback, button add event listener, click my callback. These things have to be exactly the same. And this down here won't work because this is an anonymous function and then this is a different anonymous function. Even though they are character for character identical, anonymous functions don't have any other references to them. And so you can't come back and say, hey, I want to remove that one that was anonymous earlier. There's just no way to do it. If you're looking to figure out what event listeners are on a page or you want to debug them, all major browsers have a way to discover the events that are currently attached to all of your event targets. You can find this in the dev tools. But because the event API is in the browser, it's going to depend on that browser's specific implementation. So in Chrome, what we have is you can see here, when you inspect an element, you might get the elements and you can look at the styles and you can see its computed styles and see its layout. There's then an event listener and you can see all of the things that are happening here. And so the event that I've chosen here has a before unload, it has a click, it has a focus in, a focus out, a key down, a key up, a load, a message, a reset, a touch start. And you can see then the click actually has multiple event listeners on that one event. So this element has a click listener. And this element also has a click listener. And you can click here to make sure you show the events on all of the selected elements ancestors as well. In Safari, it's a little bit different. You have to go into the nodes settings here, and you can then see event listeners, and you can see the events that are in place that way. And then Firefox does it a little bit differently. It's going to show an event kind of badge in the inspector, and will show you all of the events on that one node. And that's pretty much it. So we'll add these links to the video description, and feel free to take a look at those. And hopefully this was helpful for you. Thanks.